of rotor wash, the shudder of the deck, and the sight of something so massive it seems to defy the very air it moves through. For decades, the CH-53C Stallion family has been the backbone of United States Marine Corps heavy-lift aviation, a flying brute that carried troops, vehicles, and hope into the world's most hostile places. But even the most dependable warhorses eventually need to be reinvented. Enter the CH-53K King Stallion. It is not merely an update. It is a complete reimagining of what a heavy-lift helicopter can be. And by every measurable standard, size, power, payload, and survivability, it is the largest and most capable helicopter ever built for the American military. To understand the King Stallion, you have to first understand the problem it was built to solve. The CH-53E Super Stallion, which entered service in the early 1980s, was a legendary machine. It could carry 16 tons externally and ferry troops and supplies across vast distances. But after decades of combat operations in Iraq and Afghanistan, the Marine Corps realized that their aging fleet was struggling to keep up with modern demands. High altitude, hot weather environments robbed the older engines of power. Maintenance hours were climbing. And the enemy was getting smarter, faster, and more dangerous. The Marines needed a helicopter that could lift more, fly farther, and survive longer without requiring a small army of mechanics just to keep it in the air. That need gave birth to the CH-53K program, a billion-dollar bet on the future of vertical lift. From the outside, the King Stallion looks unmistakably like its ancestors. It retains the classic twin-engine, heavy-lift silhouette with its 7-blade main rotor and a canted tail rotor. But that is where the similarities end. The airframe itself is entirely new. Engineers used advanced computational fluid dynamics to redesign the fuselage, reducing drag while increasing structural strength. The cockpit has been completely overhauled, swapping analog gauges for a fully digital, glass cockpit with 5 large multifunction displays. Pilots now have access to real-time diagnostic data, digital maps, and sensor feeds that were science fiction just a generation ago. But the real magic happens beneath the skin. Powering this beast are 3 General Electric T408 turboshaft engines, each producing over 7,300 shaft horsepower. To put that into perspective, that is more power than many regional turboprop airliners. Together, these 3 engines generate 57% more power than the engines on the CH-53E, yet they consume 18% less fuel. They also have 63% fewer parts, which means they are not only more reliable but also far easier to maintain in the field. That is a game changer for forward-deployed Marine units who cannot afford to wait days for spare parts or specialized technicians. The T408 engines are paired with a brand new main gearbox and a completely redesigned rotor system. The composite rotor blades are wider and stronger than before, allowing the helicopter to generate more lift with less strain on the mechanical components. The result is a helicopter that can operate in extreme conditions, think desert heat above 100 degrees Fahrenheit or mountain altitudes over 10,000 feet while still carrying a full combat load. But sheer power means nothing if you cannot put it to good use. And this is where the King Stallion truly separates itself from every other helicopter in history. Its maximum external lift capacity is an astonishing 36,000 pounds. That is nearly 3 times the payload of the CH-53E. To visualize that, imagine sling loading a fully armed light armored vehicle, or an M777 howitzer with its ammunition, or even a small patrol boat. The King Stallion can lift all of them and fly them over mountains or across open ocean. Internally, the cargo bay is large enough to accommodate 2 up-armored Humvees side by side, a feat previously impossible for any Marine Corps helicopter. You can also fit a standard 463L pallet, which is the same cargo system used by Air Force transport planes, allowing for seamless integration between air and ground logistics. For troops, that means fewer flights, less exposure to enemy fire, and more combat power arriving exactly where and when it is needed. Of course, lifting heavy loads is only half the equation. The other half is doing it safely and precisely, especially when you are hovering over a ship's deck in rough seas or lowering a sling load into a jungle clearing. The King Stallion introduces a fly-by-wire flight control system for the first time in a marine heavy-lift helicopter. Instead of mechanical linkages and hydraulic cables, the pilot's inputs are converted into electronic signals that are processed by flight computers, which then move the control surfaces and rotor actuators. This system reduces pilot workload dramatically, especially during demanding maneuvers like hovering with a heavy external load. It also provides built-in stability and envelope protection, meaning the helicopter will not let the pilot exceed safe limits, even in a panic situation. That is a life-saving feature when you are flying low and fast with dozens of troops on board. Survivability has also been taken to a new level. The CH-53K features an advanced countermeasures suite, including radar warning receivers, missile approach warning systems, and chaff and flare dispensers. The airframe itself is designed with ballistic tolerance in mind, meaning critical components are shielded or redundantly placed so that the helicopter can absorb enemy fire and still return to base. The fuel system incorporates self-sealing tanks and inerting technology to reduce the risk of explosion upon impact. In short, the King Stallion is built to take a beating and keep flying, because the Marines it carries are counting on it to do exactly that. Maintenance and logistics were also central to the design philosophy. The CH-53E was notorious for requiring dozens of maintenance hours per flight hour, a statistic that strained already overtaxed Marine Corps aviation units. The K model reverses that trend. Its health and usage monitoring system continuously tracks thousands of parameters on every component, alerting ground crews to potential failures before they happen. Many parts are designed for rapid replacement, with quick-release fasteners and modular assemblies. As a result, the CH-53K requires significantly fewer maintenance man-hours per flight hour, which translates directly to more aircraft available for missions and less time sitting in the hangar. The development process was not without its challenges. The program faced technical delays, cost overruns, and the usual growing pains of any cutting-edge military project. Early test flights uncovered issues with the main rotor gearbox and the engine cooling system, which had to be redesigned. The Marines and the prime contractor, Sikorsky, now a Lockheed Martin company, worked through each problem methodically. By 2022, the first low-rate initial production units began delivering to operational squadrons, and by 2024, the King Stallion was officially declared combat-ready. Today, it is being fielded to Marine heavy helicopter squadrons, replacing the CH-53E units that have served for 4 decades. The transition is gradual, but every new King Stallion that rolls off the assembly line represents a monumental increase in capability for the Marines on the ground. What does that capability mean in real-world terms? Imagine a Marine expeditionary unit deployed off the coast of a hostile nation. The enemy has entrenched positions in rugged, mountainous terrain, far from any suitable landing zone. In the past, the Marines would have to rely on smaller helicopters to ferry troops and supplies in multiple lifts, exposing them to enemy fire for hours. With the CH-53K, a single aircraft can carry an entire rifle platoon, about 30 to 40 fully equipped Marines plus their gear, ammunition, and a light vehicle, all in one trip. It can fly at night, in bad weather, using its advanced navigation and terrain-following radar. It can lower the load with pinpoint accuracy while the pilot watches a live video feed from a sling load camera. And if the enemy fires back, the countermeasures and armor give the crew a fighting chance to break contact and return to the ship. That is the difference between a successful mission and a failed one. That is the difference between coming home and not. The King Stallion is also designed to work seamlessly with the Joint Force. It can refuel from Air Force KC-130 tankers or Navy tanker aircraft. It can be transported aboard amphibious assault ships, landing helicopter docks, and even some aircraft carriers. Its cargo bay is compatible with NATO standard pallets and containerized systems, allowing it to move supplies from a naval vessel directly to a forward operating base without repackaging. This interoperability is critical in modern coalition operations, where American forces often fight alongside allies from dozens of nations. Critics have sometimes questioned whether such a large, expensive helicopter is still relevant in an age of drones, precision missiles, and cyber warfare. But the answer from the Pentagon has been a resounding yes. Because no drone can carry a wounded soldier to a field hospital. No missile can deliver a pallet of water and food to a remote outpost. No cyber attack can replace the human judgment of a pilot hovering over a rooftop in a dust storm. Heavy lift helicopters are not just tools, they are lifelines. And in an era where the United States is pivoting its focus toward great power competition in the Pacific, where vast distances and island chains define the battlefield, the ability to move heavy loads quickly and unpredictably is more vital than ever. The CH-53K can reposition artillery batteries across coral atolls, insert reconnaissance teams b.